Hello! We're going to be doing algebraic properties, and get this down in your notes at the top of the page so it's real easy for me and Mr. McKenzie and Mrs. King to see it when we're checking your notes. We're going to apply the properties of these operations to make equivalent expressions so that by the end of this you will be able to say, I can identify algebraic properties and use them to simplify expressions.
This will probably be one of the most exciting videos you have ever watched.
Dynamic.
All right, our first property is the associative property. So copy it down and then copy down both our definition and our examples. The associative property is the way in which numbers are grouped when they are added or multiplied does not change their sum or product. That means no matter which group of numbers you kind of do first in addition or a multiplication problem, you're still going to get the exact same answer. 9 plus 4 is 13, plus 3 gives me 16. 3 plus 9 is 12, plus 4 still gives me 16. So no matter which numbers associate with each other, I'm still going to get the exact same answer. So I think of this as association is who you kind of hang out with or who you spend your time with. The 9 can spend some time with the 4 or it can spend some time with the 3, but either way we're still going to get to the same answer.
Then the commutative property, this is the way we can add and multiply numbers if we change the order of them only. So for example, if we have 7 plus 9, that ends up being the same as 16, and then it's the same as 9 plus 7, which is also 16.
So you're just kind of switching places, you're trading places in the problem.
We can move them around and then it ends up being the same thing. So that A plus B then is the same as B plus A, and we know at this point now that those are unlike terms, so we can't put them together to become AB. That's why we just say A plus B or B plus A. And the same thing applies for our multiplication. So in multiplication, we know 4 times 6 is 24, and also 6 times 4 is 24.
So make sure you have the property, its definition, and the examples. And then here's a nice little note. A good way to identify commutative property is the one that doesn't have the grouping symbols. It doesn't have the parentheses or the brackets in the problem. The numbers are just kind of trading places with each other. Last one is the identity property, and we have one for both addition and multiplication. For addition, it's the sum of an addend, a number, and 0 gets you right back to where you started. For multiplication, the product of a number and 1 just gets you right back to where you started. So these are things we already knew. We're just giving a proper name to the property. Make sure you have the property itself, the definition, and your examples written down. Now it's time to put them to use.
Dun, dun, dun.
Very exciting.
So now we're looking at two expressions, and we're going to decide if they are equivalent, and if they are equivalent, we'll decide what property was used. So for our first example there in green, we have 18 plus 7, we know that's 25. And then we have 7 plus 18, we know that's 25. And all we did was kind of switch the numbers back and forth, and because of that we know it's the commutative property.
I'll abbreviate a little bit.
Comprop.
Next one. We have 20 minus 12 in parentheses, so 20 minus 12 is 8. And then we finish the problem. 8 minus 3 is 5. We want to see, do I get the same thing if I do it in a different order? 12 minus 3 is 9. 20 minus 9 is definitely not 5. That gives me an 11. So this one is a no. It looks like they're trying to use the associative property. The 12 is associating with the 20 first, and then he's hanging out with the 3 instead. But subtraction doesn't work that way. So in this case, this would be a no.
12.
He gets around.
Then we have multiplication here. So we have 5 times the quantity 6 times 3. So that would be then 5 times 18, which gives us 90.
I'm pretty sure I got this one right.
Then we have 5 times 6, the quantity of 5 times 6, which is 30, then multiplied by 3, which is 90. So what we're seeing there is that we've regrouped them with parentheses, so we are reassociating them, which means that's the associative property.
Be careful how you abbreviate the associative property, please.
That's exactly what I was thinking right before this.
Next one, 64 divided by 8 and 8 divided by 64. Well, 64 divided by 8, that's easy. That gives me 8. 8 divided by 64 is not so easy. That actually gives me 1/8. Yeah. Or if I wrote it as a decimal, I'm going to get 0.125. Those are definitely not equal to each other, so I cannot say that this one is a true statement. Again, they're trying to use the commutative property. They're just flip-flopping the order of the numbers, but that doesn't quite work for division.
And lastly, we have two sides where 59 multiplied by 1 gives us 59. And yeah, you know what? 59 does equal 59. So what's going on there? That is the identity properties. So those identity properties are properties that you know those properties, you just don't know them as the identity property. So you have one side where in multiplication, if we're multiplying anything by 1, we're getting that number again.
All right, almost done. One last word problem. Please copy down the problem itself along with your work, so that way when you go back to review it later, it actually makes sense instead of just being some random numbers on the page. It says, at a gymnastics meet, a gymnast scored an 8.95 on the vault and a 9.2 on the uneven bars. Write two equivalent expressions using the commutative property that could be used to find her total score. So the best way to start this problem is just try one way. If we just gave you this problem and said, what would be her score? Most of you would probably go, all right, well, I'd do 8.95 plus 9.2 to get our answer. So down here, I could set up my problem. 8.95.
Well played.
Plus, don't forget to line up your decimal point. So she got a total score of 18.15 for her score. So one way to do the problem is to just do 8.95 plus 9.2. So how could I do another one that uses my commutative property?
Well, we could exchange the values orders. We could say 9.2 plus 8.95.
We know you're going to get the exact same answer, but they're just in a different order. That is our, I guess black probably wasn't my best choice.
Commutative property!
I want to see everybody say it just like that tomorrow.
You have to say it in falsetto.
But not the associative property, just the commutative property. Have a good day.